In this video, we're going to look at some special angles, the 30 and 60 degree angles. So first of all, I've got an equilateral triangle here. So I'm just going to give this side a length. I'm just going to pick 12 as the length. So this side down the bottom is also 12, and this side here is also 12. Now I could have picked any number alike. I could have even done this with using some letters like X, but I've picked 12. So 60, 60, 60, because it's an equilateral triangle. I'm not going to put that in there yet, because what I'm going to do is I'm going to just draw a line that drops from the top down to the bottom to make a nice right angle triangle like this. So I'm going to concentrate on this right angle triangle. Now, because this is 60 and this is 90, this one up here has to be 30 degrees now. And because I've split this line in half, this part of the line here is 6 from there to there. And now I can work out the missing side, this one here, by using Pythagoras. So the missing side will be 12 squared, take away 6 squared, and then I'm going to square root it. Now I'm not going to use my calculator for this. This is 144, but you can check this on your calculator if you want. Take away 36, and this gives me the square root of 108. Now what I'm going to do is just turn that into a radical or a surd by saying that's 36 times 3. I chose 36 because it's a square number, which is 6. It can be taken out to give me 6 root 3. So that's great. I know that this side is now 6 root 3, and I've got my 3 sides of a triangle, right angle triangle, and these two special angles, 60 and 30. So now what I can do is I can just look at the 30 and I can look at, say, sine. Now sine is equal to the opposite, which is 6. So sine 30 is equal to 6 divided by the hypotenuse, which is 12. And this gives me a half. Now what I could do is, what if I was working in radians? That would also be the same. So that would give me sine pi over 6, and that would give me the same value as a half. Now I can do the same here with, I'm not going to do any more radians here. I'm going to keep them all in degrees, and you can investigate the radians. So what about sine 60? Well, sine 60, if I go to this 60, sine is opposite 6 over root 3 divided by hypotenuse, which is 12. So that gives me 6 divided by 12. It gives me root 3 divided by 2. So I've got these two sine angles for 30 and 60 without using a calculator. And it wouldn't have mattered what number I started with here. I could have started with 16 or 100, but it will always end up by giving me sine 30 equals a half. You can try your own on some of the worksheets. What about cosine? So let's go to cosine 30. Now cosine 30 is adjacent divided by hypotenuse. Well, that's simply 6 root 3, the adjacent divided by 12. Well, we've been here before. It's the same as this. Root 3 over 2. And cosine 60 is the same as sine 30, because I'm doing the adjacent 6 divided by 12. What about the tan? Tan 30. Let's go to the 30 angle. Tan is opposite divided by adjacent. So this is 6 opposite divided by 6 root 3. Now the 6's can cancel off and we have 1 root 3. You may see that written as root 3 over 3. These two are the same thing. And then tan 60, we go to the 60. Opposite is 6 root 3 divided by 6. And that gives you just a root 3. So these standard angles, the 30, the 60, the cos 30, the cos 60, tan 30 and tan 60, they will always end up giving you these ratios at the very end, whatever numbers you start with.